All right, so we need to do shifting rules, which will be a la Algebra 2 here. I promise it's exactly the same stuff, okay? So I like to remind you that what I'm talking about is going to be the graph of a function. You guys all with that?
Yep.
Okay, so here's my general picture for a function, right? It's a name f. It takes some, like, I don't know, what do you think about the inputs as being? X's.
Oh, going that way? Oh, yeah.
And, yeah, it outputs y's, right? You guys cool with us?
Yeah.
So I'm thinking a function f is a rule that takes x's to y's in some special way, right? You could think this is the sine function, or the cosine function, or the tangent function, or any of the other functions you know about, right? E to the x, or log of x, or any of these other kind of horrible things from Algebra 2. Cool? Don't worry about what it is right now. For this lecture, I'm going to call this thing the rule. Okay? So this is the function I know the picture of. This is the one I'm thinking about shifting. Okay? This is the function I know how to graph. Or this is the function that looks like the graph I'm confronted with. Okay, see that? So in my kind of motivational bit, I was talking about some oscillating shape, right? So when I see some oscillating sine wave kind of thing, I'm going to look at that, I'm going to think sine or cosine, right? So that's going to be this rule that's happening. Let's go with that. Then on each end of this, I'm going to allow for modifications. Okay? You guys want an example, or do you want me to just give you the general thought? General thought? Okay. So the general thought is that there are going to be beforehand modifications and after modifications. So stuff that happens over here, right? So if I put more functions on the beginning, what are those going to change? So these are going to be before the rule things. So things that happen before the rule, what are they going to change? The x's or the y's?
X's.
Yeah, they're really modifications of x, right? Okay, so modifications I'm going to allow for x's are going to be, okay, if I add a number, right, what does that do? It shifts something.
Oh, shift something. Oh, okay.
Left.
Yeah,
Right?
left.
Left?
Left. Because of the parent formula. Right?
Okay, so this is a horizontal shift, and we should figure out which one, right? You guys with me on that? Okay, so let me think about by example. Okay, what's a function I know the graph of that's easy? Like from Algebra 2.
X squared.
Okay, let me give you my favorite example. I'm going to go with f of x is x squared, right? Okay, now I'm thinking about, I'm going to do add a number to an x modification, right? So that's going to look like, okay, I'm going to look at f of x is x plus 3 squared. You guys see that? So I added 3 to this thing before I square it.
Yep.
You guys see how that's happening before the rule? So the kind of blob picture for this is I start with an x, then I add 3 to it, I get to x plus 3, then I square that, and I get to this rule f, right? You guys see that? Oh, I should really always do it. So the rule F that's happening is here. That's the one I recognized, right? The one I know how to graph. And what's happening beforehand is I'm adding 3. Okay. Can you guys all tell me where the vertex for this thing is now? You guys remember that word?
Yeah, it should be like 0 minus 3, 0.
At 3?
See, how about this? If I plug 0 in to this thing, what do I get out for a height? 9, right? Okay, so I know up here someplace is the point 0, 9. If I plug in, I don't know, what's your next favorite number?
1.
1. 1's a crap choice. It's a good favorite number. Why is 1 a bad choice here?
That's 16.
Because I get 16, so it went up, right? And really dorked my picture. What if I went back 1?
Minus 1.
So I think I get 4. What if I went back 1 more?
1.
1. And back 1 more?
0.
0. And back 1 more?
1.
1 again? Oh, that's nice. Now I'm seeing the parabola that I was looking for. Right. You guys see that? Okay, so what happened? When I added a number, a positive number, which way did it go?
Shifted to the left.
Yeah, so what I found out is that if I modify x's, I add a number, it's a horizontal shift, right? Because it's modifying the x's, and it's a shift left. You guys cool with that? All right. How about, what happens if I flip the sign beforehand?
Goes right.
No.
What?
Sorry. Let me go back and answer the question, or give you the question that you're answering. What if I subtract the number? Then it goes right.
Yeah.
Okay? I'm not going to write that here. Right?
Yeah.
Subtracting is the opposite of adding, so shifting should just go the other way. All right, what else could I do?
Multiply.
Could flip the sign, which is what I was trying to ask. And if I flip sign, what happens? So remember, I'm modifying x's still, right? This is still happening on this side before the rule. So if I flip the sign, I'm flipping the x's over.
So it'll stay in value, but just change in the location.
Yeah, it'll flip around the
Y.
y-axis. Right, so that's one of these. Right, that's a horizontal flip. You guys cool with that? All right, what if I multiply by a number? This is going to be the confusing one.
It stretches vertically.
Okay,
Yeah.
I'm going to put in here, I'm going to multiply by a number bigger than 1. And really, I should be saying multiply by a positive number bigger than 1, right? I don't really need that distinction here because I said it was bigger than 1, not bigger than 1 in absolute value, but I know how you guys think, so don't screw it. Okay. Positive number bigger than 1. If I multiply by it, what happens? There's some kind of you guys remember?
Stretch.
Yeah, this is like a stretch or compress, and I can never remember which one. You want to do an example to figure out which one it is?
Sure.
You got a guess on it? Wait, record your guess in your brain. All of you, guess. Stretch or compress, and then we'll figure it out. So, how am I going to make a function that does this? I want to keep my rule f, right? My squaring rule. And beforehand, I need to multiply by a number bigger than 1. So what's your favorite number bigger than 1?
2.
2. Okay, so I'm going to multiply by 2 here. So that means what? What's my function g?
2x.
2x.
2x all squared,
Mhm.
right? Okay. So picture. Where does 0 go?
0.
0. Okay. Where does 1 go?
4.
Okay. Where does minus 1 go?
4.
4. Okay, so there's g, right? For everyone, like this.
Mhm.
Now I'm lost because I don't remember what f looked like. Let me graph f in blue and then we'll see if we can figure out what the difference was. Okay, so what's f look like?
One is 1. 2 is
1 goes to 1, minus 1 goes to 1,
Mhm.
0 goes to 0, right?
Mhm.
And then
Which is why
2 goes to 4.
Mhm.
Oh, so what happened?
compressed.
Oh,
Yeah,
compressed
compressed. So,
horizontally though, right?
yep, so there was a horizontal compression there. You guys see that? Okay. So, multiply by a positive number bigger than 1 is a
Horizontal compression.
horizontal compression.
Isn't it also a vertical stretch?
Oh, good! Awesome! You guys see that in this picture?
But I thought it was already going to go infinitely up anyway.
Yeah, it was. Please note, look, to get from blue to black, right, I could think about a horizontal compression. Or I could think about this as 4x squared.
Mhm.
You see that? And then instead of this being my picture, when I put an x in, where do I start? So what's the first thing you do to an x in this function rule?
Like square it and then
Square it, right? So there's your rule f,
and then multiply by 4.
and then you so you get your x squared, right? Then you multiply by 4. You guys see that? So your rule g is right here. But when I thought about graphing g, it was also there. You guys see that? So I have two different perspectives on g.
Okay.
Right? One I got by modifying the x's by multiplying by 2. The other one, this modification happens on what?
The y.
On the y side, right? So I should need to add some, like, oh, there's like some stuff that could happen over here, right? These are after the rule modifications. You guys see that? The before the rule modifications, those modified x's, right? The after the rule, those are going to modify,
Y.
yeah, those are going to modify the y's. You guys see that? And so I've just discovered something. If let's see, I don't know add a number, I don't know flip sign, but I did figure out multiply by a positive number bigger than 1, right? In this case, I picked 4 for some damn reason. And what happened? So to get from blue to black,
It stretches.
yeah, with the orange thought, I'm stretching this way. You guys see that? Right? When I multiply this height, right? 1 by 4, I get 4 out. You guys see those two different thoughts? So the before the rule thing was
Horizontal compression.
was a horizontal compression, and now I'm noticing that I could actually write that horizontal compression for this function as a vertical stretch. That's not always true, right? Those are sometimes different, but with this specific example, they're the same thing. So modifying, multiplying by a positive number bigger than 1 is a vertical stretch. Right, and that's if it happens after the rule. All right, I think I can probably figure out these other two without messing around too much. So I think I've got add a number. You guys all remember if I add a number after the thing, what happens? Yeah, it shifts up, right? So this is a shift up. Ah, how do I get down?
Negative.
Yeah, add a negative number or subtract a number, right? And then what happens if you flip sign?
It rotates around the x-axis.
Yeah, this flips over the x-axis. Cool. So there's your whole set of shifting rules. Now you are responsible for figuring out whether things happen before or after the rule, what the rule is, and how to put all this together. Which is not super duper easy.
I'm thinking of sign not as in the tangent, or not tangent, but the trig sign, but sign as positive, negative, right?
Yeah,
just
sorry,
wanted to make-
these
yeah, okay,
signs
okay.
are spelled the positive, negative.
Okay.
Yeah, so those are
Those-
multiplying by -1. You guys see that? Those are not the trig sign.
Okay.
Yeah, the trig sign and this sign get a little funky together. There's an odd function thing. You guys want to see some examples with trig functions?
Yeah.
Yeah.